welcome back in the third and final part of the tutorial. So yeah, now it's all going to be about like the final touches, the last elements, and we're going to look as well a bit at tech passes and compositing all that together. So yeah, like the first part that we can start to do is this one is going to be called what I call here under surface. Is basically just going to be just to give a bit of thickness to our effects. Currently it's a bit thin, but like, you know, we want to basically have some matter inside, just to give a bit more thickness. So we're going to have a look at how we can basically scatter a bunch of points, attach them to our sim, and yeah, like totally procedural, so it's going to be pretty nice and easy. Then we can have a look at those two as well. Those were just like 3D rays that I added just to give like a special glow, and a bit of smoke coming out of the eyes. So yeah, like those are like the three last layers per se that we didn't work on. I'm not going to go through like those two smokes. Basically, like those are just two different smoke with different values. This one is a bit denser and this one's a bit thinner, and it has this one's a bit more brilliancy, just to get a bit like more low density, high density contrast in the smoke. But that's we can totally do that with what we saw in part 2. So yeah, those 3 layers, and then just the AOV part. I think I have it here as well. AOV breakdown. Yeah, so like a bunch of stuff here. We got some stuff that I didn't even use at the end, to be honest, this ripple thing. But yeah, there was some, the distance to this is pretty useful. The activation age as well, basically like to give an extra glow on when it's detaching, can help a bit to sell the effect. The ripple here is, so basically like what we try to do here as well is like we render the mask with 3 different shading. So we had like the pretty, like the normal one, a bit cleaner. Then we have the more rusty version of it. And then we have even like a lava thing. So basically here the idea was to do switches between the 3 different ones, so that way you would get like a feeling of like the mask as well, like the surface of the mask is being displaced as well by this disintegration effect, on top of all the mesh lights on this, of course. But so basically here we have those basically where we just decided like sometimes you can render do the switch directly in 3D and then drive this with a mask directly in 3D. But the problem is like if you want to tweak a bit the timing of it, then you're a bit stuck. So that's why I just rendered all the 3 full frame range, and then I do a shader switch with another pass that is just emissive, so very, very fast to render, and that way I can even like tweak some stuff in the comp. Then we have the groups. This one we already set it up, just basically to isolate the back faces, the edges. We know how it works. And then we have some noises as well. I like to output some noises. So I actually, we have some, those are actually flowing, but we have some flowing and non-flowing ones. Just to like, you know, get a bit more variation, you know. All you see here that are in the R, G, and B, like, you know, we have some funky stuff, funky colors, of course, but basically the reason why is like, you know, we're using the 3 channels, and so like in red, green, and blue, and like that way we can have like a very good anti-aliasing, and like we don't need to render like all those layers separately. They can just be stored in 2 different channels. And then like in Nuke with a shuffle, you can directly easily just pick, okay, I want this ripple, I want this one for this one for this part, and it's pretty standard workflow that we use now in compositing and production. So yeah, let's get started with the with this one. All right, cool. So in this example, I think for now I'm just going to like just show you the scene that I did node per node. I'm just going to retype everything, just that way like we'll get it done a bit faster. But I'll explain every node and we can see. So basically here we're going to have a look at this inside layer now, just to give a bit of thickness. You can see that if I remove it, it looks pretty flat. So yeah, adding something inside really helps usually. And also, like if you render this as a separate element, you can get a bit more glow on this one. So it's always nice to have. So basically, how does that work? We take our mask, you know, VDB from polygon it, and then I just erode it a bit, just because I don't want to have something that is too close from the edges. Like, you know, if that makes sense. Like here, this is our surface. I don't want to reveal this under mask before, so basically I'm just like erode it a bit. Cool. Then I'm just doing a point from volume that will fill up this with points. And here with the point separation, you can actually change the density. So like how much point you want inside. Here in my particular scale, it was 0.02. So I have around like 25 million points. I like as well to directly put this one, add scale attributes. That way, like you can see that it will automatically adjust the size of my point in the P scale. And that way I don't have to worry too much about it. I can try prototype something with in low res and then go back to higher res. And like the P scale will match, you know. Cool. Then we take our geometry, so like the our mask again. We do a vertex split just to have like proper working UVs, and then we transfer the UV back into the points. And you know, we can actually then have a look in if we do the attribute from map in the CD, like, you know, we put like a texture or something, like you can see that we're generating the UVs. This is pretty useful if you need to have the colors just to blend a bit more again. Well, you can use that. Cool. Here basically what we do is kind of a gradient. I just do here this gradient to like on the distance from the edges. So basically what I just do here, I take the shell, the geometry, I scatter a lot of points on them, and then I do just a near point. So here it's pretty subtle, but like, yeah, basically here doing near point, I take the distance. I do like, I can calculate the distance between the nearest point and my point, and then I can fit by 2 values, and I have something between 0 and 1. And so if you see here distance, you see you have those values. I think at the end this is fairly optional to do this, but it can be useful if you need to store this as an AOV, or if you need to multiply as well the amount of displacement by this. Here we're just on the side, I just check that the names are working. Like, you know, we transfer the name here, and so you can see that's like now our stuff is moving as well. So it's kind of matching. Kind of matching our stuff. Sometimes we have like few artifacts. Those are like because we have some crazy rotations and all this. So that's why at the end I didn't use the transform pieces. I used more point deform, but we'll go into that in a second. Here, just the rest position, storing that, and then I just store some noises, just for compositing, like, you know, the same technique that we did. I can like I'll do a fresh reminder super fast. So if we go to FX output, and I'll just try to inside Disintegration. It's the same particle shader thing. So I just give those noises and into separate AOVs. So like with Arnold, we use the user data RGB, and I store this, you know, in AOV write RGB, and then in the in the Disintegration, just need to find it. Properties and output, you know, we can just output those AOVs as well. Live and noises. Cool. Yeah, that's just like basically for shading that I use that, because like, you know, that way I can easily remap a bit the color and have something that looks a bit like lava. That was like, you know, the idea of it. So yeah, you're obviously a bit too bright, but you know, just for the test, this would be something like this. So yeah, basically I'm just storing those noises here, and then so this is basically what I do. We have the mask in the rest position, and then we have the mask moving. So basically we just put the rest position version and another rest position version, and we do this point deform thing. So yeah, like in this case, it got rid of some of the extreme pieces. Gonna go here. Like you can also, like, you know, adjust the radius, the maximum points. So basically, those were like the number that worked for me. But it's a very simple technique, right? We're just going to we scatter a bunch of points inside, and then we just use our main simulation to point deform it, so they can follow it. Here we have a p-scale multiplier. At the end, we didn't. This is useful when you do your tests. You can just make them like those particles, whether bigger or smaller. And basically here the idea was just I wanted to get a bit more stretching. So if I were to go here, yeah, just getting a bit more stretching. So basically what we do, we have the same version but just fully parented. So this is not taking the our point cloud of our sim. This is just taking the extract transform of our mask. So, like the single point that stored the pivot, the orient, and all this. And then I'm just going to transform our inside particles on the one stream. So, you know, that way we have that. I'm just going to go on the last frame so it can be a bit more visible what we're trying to do here. Basically, we have all those points moving to match the animation. Those ones that are point deform according to our sim. And basically here you can do a blending. So to blend this, you can blend with something called lerp. And basically lerp is a bit like a blind shape. So I'm just going to see, we just need to give the exact same points number and point order. And then you can actually say, okay, I want you to blend between the position, your current position, and the position of your PT num in the second input. So yeah, basically here we're just doing a rand PT num, and then we're multiplying this by a noise. So like, you know, a noise that we stored here, just to get something a bit more organic. And then, like, you know, we're blending between two. So if I were to go 0, like, you know, here there's no blending, so this is like fully the same thing as here. If I were to go 1, you know, like here, like you see we're getting a bit more stretched, you know. So you can play around with this. Here, obviously, like, you know, if you were just to do like a full rand equals amount, you can see that we're just, you know, doing this, going really blending between the two. So then, like, you know, we're like when we do times this rand. So like if I were to, for example, just remove this part and then just multiply by rand ptnum, like you can see like basically some of them were like go to 0, and some of them will go to your threshold amount maximum. So here it will be 1, and then like adding this noise thing, it's just going to like get some more interesting patterns. So yeah, basically like here, you know, it will just basically like store a value between 0 and 1, and then it will multiply all that. Sometimes it can get a bit heavy with the capture of the point form. But yeah, that's really pretty much it. So just here the only kind of trick was to get a bit of stretching here. Cool. Then live here noise. Yeah, I think it was just some custom AOVs. But pretty much it's like a pretty simple technique. But like you can just add a bit of thickness in our effect, and then we can treat this one a bit separately. Cool. So maybe now we can go through, let's go through the volume raise. All right, cool. So for the raise, pretty standard workflow at the beginning. It's a bit the same way that we did to source debris. So we're just, you know, taking the geometry. Like here in this case, I'm just taking the outside part, so like the what's called back. I'm just computing the normal, smoothing this up. Then I just scatter a bunch of points, rest position, and then I do, you know, the standard find closest cluster 2. The same thing we did for a lot of secondaries. So this, I calculate the distance, I find the thing, I create the IDs. Here I think I just retransfer the normal, and then I, you know, after that I transform pieces to match the our simulation. So basically here the idea is like we're just going to store when those pieces are detaching to each other, and we're just basically going to store an attribute called active frame or source frame, and it's basically just going to tell us like when are the two pieces are detaching from each other, and from that we'll be able to create the raise. So after this, you know, we have like this section called activation solver. So that, you know, we're going to give a very high number of active frame, 9999. Basically, like if this number stay the same, that means like it's never going to be activated. And here we're doing a small condition, so we're just going to say if the distance is higher than this threshold, you activate it. So here, like we have this visualizer here. So basically all of those are going to be activated. And basically now we need to store the frame on which one, like which frame are those getting activated. So to do that, we have something called a subsolver. So you can just type solver and you will get it. And here basically the idea is just to say, so if active equal 1, active frames equal frame. So like, you know, that this is something that we don't actually need a solver to do. Like, you know, we could already put this one outside. But the thing is basically like, for example, let's say those are active. So active frame then equals 72, but then those are still active, 73. So then like, you know, we're overriding each time the frame number. We're looking for the first frame, basically like, you know, the frame where like this pieces is turning white, and like this for every of all the different pieces. So in order to do that, there's that's and what we did this very big 9999 is basically like we say, okay, so we're giving you the frame. So if active equal 1, we have active frame equal frame, but we're also doing, but you know what, it's also the minimum between your current active frame and the frame before. So in this case, what's pretty cool about this is like if it was something like if it was already activated on the frame before, like so let's say we're at frame 24, and we're going to look at frame 23. We're going to say, were you activated at this point? If you were not, then you will give me 9999. So basically, I will note 24 to be your source frame. But if you were like already activated, I will see a smaller number. So I will not. I will just keep the smaller number between the two. So that's a cool way, basically, just to have this minimum solver. And the good thing about this is that we can, after that, just put a time shift and actually just bake only one frame. So you can see here that we have like a static cache, but we have a very handy attribute, active frame. And if you were to visualize it, we could just say CD equals feet frame active frame. Then again, active frame plus duration. And we're going to put 1 and 0. And here we just need to declare an integer, so duration. So like this is going to be the number of frame. Duration here. So now if I put 10 frame. Alright, cool. Can put the opposite actually, 0 to 1. So you can see that now stuff are going to appear gradually. You know, so that's really cool because like now with just this single frame, we can after that have something time dependent. The good thing about this is like you don't have to load every frame. You're actually just loading one data, so it's efficient for you to work. Like you can see, like we're like scrolling real time. It's also efficient for you to store. So like if you can with like, you know, those kind of propagation effect, and we're going to talk about it in a few as well, but if you can store just one frame and an activation frame, usually it's a bit better. That way, like, you know, you have way more control after that. So that was the that's the whole idea. So just, you know, just to recap, we're like giving a very, very big number, active frame, then we're activating, and we say if you're white, then active frame equal frame inside the solver, and you just say, but also you're the minimum between you and your frame before. Fairly simple stuff, but very handy. So yeah. Once we have this, so we're just going to like give it back to Raspos. And here we're just going to delete all the very big active frame thing. Like because we don't really need them. You know, here we'll go from 3 million to 400K, so it's already better. Here it's 150 because I go until 125. But like, you know, you can do like dollar RFN like this, you know. That way, like, it will work in any case. Cool. So then what I do here, I basically promote the active frame per cluster name into minimum. So this to see a bit what it's going to do, but basically like it's just going to say, it's going to look at all the cluster cluster name. And I don't know if you can see the color. So let's keep what we did before. Okay, and now we can just, you know, so we had this. You can see that even between the same piece, some of them were actually like continuing to grow and all this. Here, basically, I just want to simplify a bit and just say, you know what, like just take the minimum of each piece. So like you can see that now it's actually spawning a bit more per cluster. So we have something a bit more snappy, but like, you know, again, you can try this one, or you can also try, you know, the other cluster name, so 2. So like, you know, you would get something that is, yeah, way more per pieces. But you can see even the difference between not promoting this and promoting this. We're actually going to have something that is a bit more snappy. So that's the idea here. We're just giving a noise. Here I do some offsets. So basically I just offset based on this color. So if you're if you're at 0, I'm not going to offset you, but if you're at 1, I'm going to offset you by 5 frames. And here I just do random offsets, just to break it up by random. So like, you know, that's a cool thing as well with this active frame workflow, is that you can, so if I were to do this, you can see that now I'm getting something a bit more broken up than before. All right, cool. So let's go back to the, all right, you can see here there's some of them are offsetted basically. That's what you need to know. Then of course, after I just retransform to our simulation, and here I transform, I just give back the normal. Alright, it's a bit big, but you get the idea. You can, if it's too big in the visualizer, you can go to guide and scale normal. You can go to give something a bit smaller. You can see that it's basically this. Because now we know we store just one thing, so it's just one frame. So it's just important to just give it back to normal. So we are recomputing this, by the way. Cool. So now this is basically the duration of our arrays. So you can see that now we're doing the same thing, the exact same thing that we type here. So we're giving a duration here, 30 frames, and then I just remap it with a ramp. And you can basically let, you know, it starts. It's going to start at 0, but then quickly go up to 1 and then fade off. So that's basically like the life of my arrays. Here I do some tweaks on the N. Basically, why we want to keep this N. Here the idea is like we're going to, you can see actually that when we go to normal mode, this is already a bit looking like rays. So the idea is like we're going to shoot basically like those particles along the normal, and that way it's going to create some lines, and it's going to make them look like rays. So that's why, you know, by smoothing a bit the normals, we're going to have something a bit more soft and pleasant, basically. Do I do something else here? I just, yeah, normalize it. I just do a lerp as well, just to, you know, have something that points a bit more towards camera. So basically, here just have a noise, and basically here now it's like where we're creating those rays. Wow. So thing here, those are a bit extreme. So basically, yeah, here like this is like the place where, like, you know, you can actually do your test, do your timing and all this. Here, like basically the idea. So like, you know, we had all those points have an ID, and so we're just going to merge like the moving ones, and we're going to offset them along something. So like, you know, here we're just going to do P plus normalized version of N. So like, you know, the direction that we set. So if I were to tweak N here, you can see that it would get more or less, you know, more or less smooth. So I think we're at 0.6. And we're also like, you know, we're going to tweak the length of the rays, how long we want them to be. So we're just, you know, multiplying this. We're offsetting the position along the normal times a color. So like the noise that we're putting here. If we don't have this, like, you know, we have something that is pretty flat, it's the same everywhere. So this this color is actually driving the pattern of our rays, you know. And then we have our multiplier, you know, if you want something big or not, and then a random just to get a bit more variation, basically. If we don't have, we can have, like, you know, it can work as well, like we can have something a bit more stretchy, I guess. Like, you know, that could be an option as well. But anyway, here I'm actually asking, maybe they're breaking the yeah, sometimes, so they can, like, this random actually broke something. So the best sometimes is actually to put this rand ID in a float and then multiply it just to, yeah, okay, that's better. Yeah, before it was actually doing a 3-vector randomization, and so it was breaking a bit too much the look of it. All right, so basically that's the whole idea. Now we created those lines. After here, we're going to just remap with the same technique. Like, you know, this is parented to the live fire array. But it's more going to be like how the intensity of the array is going to evolve. So like, you know, we're going to start low at 0, and then in the middle is going to, it's after 15 frames, going to go through the peak of the intensity, and then it's going back to 0. So that's pretty much it. And yeah, actually here our color was driving the noise, but not only the noise. It was also like driving the animation of the thing. You can see that, like, we have those moving because, like, we put the ray, like, we put all this information here in the color. So that's about it for this. Now we have, like, several noises as well, just to get a bit more detail after this. So those are basically just, you know, we're multiplying by a noise, then another one more high frequency. Usually it's a good idea to have, like, 2 noises, like one more low frequency, one high frequency. Just give something more organic in general. And then, so basically, like, we're going to turn those lines into volume, just like to make those a bit more appealing, and like to have something a bit more yeah, like we want, like, to make this a bit more volumetric, to see a bit more like if it was light, basically, like, you know, and then we would get some something a bit smoother as well. So the thing is, to do that, we need to convert those lines into, we're going to resample them, because basically, like, we need basically to say Houdini, like, create data in between the line, you know. So that's basically what we're doing. Then we're just, you know, here I just delete and I just keep the points. You can see that if I do without the resample, this is basically what Houdini is getting. So like, basically this can help you have some sharper volumes. Basically, that's what you need to remember. And usually the the length of the resample is linked somewhat at some extent to your P scale. So yeah, that's about it. Here we're just going to store the color. We're also resample, create a cool attribute in general that we do, like in FX, it's called curve view. So So like I can just enable it here. And basically, like, it's basically just a ramp from one side of the line to the other. And so here, obviously, I want the opposite. So that's why basically I'm just doing this. Alright, and basically just saying like I want something more intense at the base, and then something that, fade off after that. So I'm just storing like this color, multiplying the color by this, and then I'm just storing the alpha. And the density alpha is purely just for me to visualize it in the viewport, but like the density is going to drive our thing. Cool, and then I just have to rasterize the density. Here in this case, I also rasterize the color, so that way, like, I can easily ramp my stuff, and then I can just render the symmetry volume. And in terms of shader, basically, it's a very simple one. Just find it here. Raise volume. So here we have like a standard volume, and the only thing I'm doing here, I'm just putting a volume sample RGB, and I'm just giving CD and then putting this in the emission color. That way, like, it's just going to, we're just basically baking the color that we want. So that way that gives a bit more control, and you can go a bit more crazy than just, it's not just something that you would, it's not just going to be like remapping the density from it. It's actually, you can actually do whatever you want. I mean, I guess you could do it in shading directly, but I just usually prefer to tweak my colors in SOP. I think it's a better way to visualize it, and then passing this data to directly to the render baked. So yeah, that's about it for the raise. So like, if I were to, it's like a pretty subtle effect, but like, sometimes it can just, it looks a bit cool, like it looks a bit like lens flares, a bit like magical things. For some previous projects I used them, they were like a bit bigger part of the final picture. So yeah, just like, I just thought it would be interesting to show you guys how to do that. Those like shooting rays. Obviously here in the viewport, they're like pretty visible, pretty strong, but then comp will tone them down. Alright, so that's it for this one. Next, I think in our last non-tech pass, last layer is going to be the smoke coming from the eyes. So yeah, pretty easy effect, but it's just like it's something that comes back quite a lot. I remember like on several video games trailers we had to do some stuff like this. I think there was this on the World of Warcraft as well, like the King Lynch or something. So yeah, that's a pretty like interesting secondary effect that we can add just to make our shot look cooler. Alright, let's start it. Alright, let's go for the last secondary. So for the smoke eyes, so basically I'm just going to take our guy, just freezing it, subdividing it, and then I'm just keeping the eyes. Basically what I do, I just do the simulation on one of the eyes. So basically here I think I choose the left one, and I keep the part that I want. So here I just did like a very dirty manual selection like this, but I just wanted something, oops, I just need to go on the final frame. So I just wanted something that, like, just isolate the part that is visible and not basically sourcing from behind of the eyes, Subdivide that again, scatter a bunch of points, do a noise rest thing, keep just, have a moving flow of color, and then just keeping the values underneath this color, and like basically on this noise I have something that moves along the x-axis, so that way, like, we have this traveling noise on the left. After this, basically I'm just going to source particles. here the main trick that is giving us those nice looking curves, we're going to advect and create our own velocity field. So to do that, basically I just go back to our good old guy. This part is going to do the veil field. Here we have like several meshes. So something that works pretty well when you don't want to deal with several meshes is you just place the grid. So here I just place a grid in front of the guy, and then just project this along a vector. So here was -1z, and that way, like, you have something that matches pretty well our thing, but is actually just one mesh. That way you don't have any poly extrude problem, and like you have something that works pretty easily. Then I just like draw some curves, so you can see here. Try to get something like what's important is that we always keep the same direction when we're drawing curves. So here I always try to go from the inside and the outside like this. Like don't need to draw too many. 3 in general is good enough. Then I just resample it. First time resample very low count, and that way the other one, if we switch to subdivision curve, we can have something that is looking a bit smoother. Then basically I just use the normal from the tangents, so it's creating those attributes, and then I just do v equal minus normalized version of the tangent. That way it's going to go on the other side. I don't know if you see it. Sometimes you don't see very well velocities with lines, but basically you can just visualize just the points and you can see. Here's still a bit long, so again we can just reduce scale vector and you can see the trail is pointing that way, so that means we're good. And then here I just do the bounding box of this part and do point from volume, create an empty veil, and then just transfer the velocity with the blending width. And basically I just notice this velocity and then rasterize it. And then like you can actually put a volume slice and a volume trail, and you can actually see our flowy bit. And so yeah, that's it. That's the creation of our velocity field. And just to come back on this, then like that's why we have this traveling noise. But then we're also, so we just need to, well, you give pretty short life expectancy and life variance, and in the pop type baked by volume, you can just switch by V and not vel, and you can just point it to it and stop. And it should give you something like this. Something that looks pretty organic because we have some, we're varying the emission source over time, and it's kind of matching the shape that I wanted. So yeah, that's about it. Cool. Then I just select some of the attribute that I want to keep. I noise the velocity. Let's go back to 1. Can actually go from here to here, give some flowy look. The way I don't know if I already talked about it, but the way I just like to do is I just normalize, I store the speed in attribute and just normalize the velocity, and then I just I add a noise 0 centered, and then I just normalize again and just multiply by the speed. That way I feel it's the way that looks, they give me the most control, because I can reduce the amplitude if I want less noise and all this. So anyway, then I just store those attributes, so density and temperature, and then I just multiply this by nh. So nh is age divided by life. So that's the two things that we put this inside the pop solver directly. And I just use the complement, so 1 minus. If I don't, it's going to start dark and emit fully at the end. I want to do exactly the opposite. Source more smoke at the beginning and then gradually don't source anything. So yeah, and then I just like put CT gold density. Cool, then I rasterize this. So and I put density, V, and temperature, and then I just, for my personal preference, I just like to put the velocity under invisible display. Cool. In this case, I'm using Axiom for this quick test, but obviously you can do it with a normal dot. There's nothing really. It's basically we're just going to give the velocity. Here we have the collider as a VDB. Merging these together. We are sourcing a bit less temperature. See, something that dissipates pretty fast. Yeah, nothing really complicated. Like our first velocity field is doing most of the work for us. So then, like, it's just and it's a pretty subtle element, so it doesn't need to be even that high res. We're just pushing the velocity basically. Here I just put a pyrobake and a small in the visualizer, so that way I can, you know, we can work with the witness cams. Sometimes, like, you know, it helps a bit. Do I have, yeah, render cam close up? No, cam eyes, yeah. So, you know, you give a bit of fire in the thing, just a bit of emission, and you can actually judge the motion of your sim. But yeah, like, this is like, we can reuse the same thing that we did otherwise for the other smoke. It's gonna work pretty well. You don't even need that much buoyancy here. It's just basically a bit of shredding, and that's what we need to do. Alright, so here we have our smoke. That looks pretty subtle here, but like we're going to merge it after that. And then after, what you just need to do, you just need to parent it back. So I just duplicate it and then just parent it back to the eyes. So, you know, just pretty simple. Here is our same transform of human, and here I just had to recalculate for some reason because it was not matching properly on one of the eyes. I think it was on the left one, but basically it's just reattachment. Now you get 2 VDBs. I prefer to work with one usually, but it depends, like, you know, but here in this case that's what I did. So I just created empty density VDB, empty veil VDB, and then just VDB combine. I put all the data into A, so it's going to be A, and I resample A to match B. That way, like, you know, we're always keeping the same resolution as the input. And I think here I just rendered this with a pyrobake. So yeah, in Arnold, to render with pyrobake, you just need to bake the emission volume into CE. And after, you just need to put CE into the emission color. Yeah, so yeah, that's pretty much it for the smoke eyes. So yeah, like here, biggest thing is getting your veil filled that drive your particles right. Once you have the behavior you like the smoke thing is pretty secondary, just like dissipation basically, and but there's nothing too much to, don't need to overcomplicate it. Alright, so that was it for the last effect, the last secondary. So now I'm going to talk more about the tech passes. So yeah, this AOV breakdown thing. So basically, like, you know, here I rendered stuff with different shaders. So, like, you know, you can try different things. Like, personally, this was done with Substance Painter. I'm really not like a texturing artist, but like like with some mask and stuff, some stuff like this, you can do already a pretty good job. So here the idea was just to render 3 times the main disintegration effect, and then add something that is totally independent, that will store a bunch of data and AOVs and tech passes. So basically what I decided to do, and also like that's one of the limitation of Arnold GPU. You can't have deep for if you render with GPUs, and all those were rendered with GPUs, those 3. So I decided to render like a tech pass with just an emissive shader, so it's going to be very fast to render in the CPU. And that way I can have deep as well. Like, and that way I don't store 3 times the deep, I just store 1 time the deep in the tech pass, and then those are like just going to be our RGB passes. So yeah, that's really about it. The tech pass now. The tech pass, I want to just render a very high dense scatter. So here I think we'll have like 10 million points. We're storing like the usual attributes, UVs, VP scale, and all this. And yeah, like here we have like several stuff that we do. So I can start with the bottom, this very easy ones, or just store some noises. So here you can just, a time shift 1 frame. All right, you can do about it. There we go. Just freeze 1 frame, back to rest, and then here we have like a bunch of noise. So and with different frequencies, doors are not flowing. Here we have like the flowing noise, so with like some offsets, so you can see that they're moving over time. And yeah, basically after this, I just create an attributes, put the first one into the X, the second one to the Y, and the third one to Z. And that way after this I have those funky looking AOVs. And yeah, some are moving, some are not. That way we have more control, and then just after this attribute copy back. So like that way I can still play around with the timing of it separately, and then when I know it's good, I just copy back the data to the mainstream. Cool. So we can talk maybe about this AOV, the shader switch. Here that like is also called as growth solver. So here I just take the thing, remove some points just to make it a bit more fast. Put a sphere, transfer the color. And this is going to be more or less the same technique as the one we use for the rays. So we're putting a high number in the active frame. Here this is like an interesting technique as well. It's just like we have a noise that multiply our activation. So here I just basically parented this noise to this one inside, just and here I add this noise first frame and I do a max of the 2 colors, and this is the thing that is going to give back the color basically over time. It's a bit confusing, but basically like it's going to give us something a bit more organic when it's traveling. And basically like the attribute transfer here is something you can animate, and with this you can just basically change how fast it's growing. So once you have this, you can just say like or like, you know, maxing the color, so that way it's not retransferring to something that is not purely white. And then like you just say if the color is higher than 0.9, we do this exact same thing. We store an active frame, and yeah, that's pretty about it. So then we're left with one frame, and then we can have several active frames. Or like this, yeah. So like, you know, see that those patterns are like coming from the noise that is moving. It's going to break up the very circular shape. But yeah, basically here we have like different duration. So here like we have a fall off of 5 frames. Then this one I'm just decided, oh, that'd be cool to have like something offsetted. So like I would offset the animation by 40 frames. And this one I offset it like by minus 30 frames, so it's already present at the beginning of the shot. And yeah, that's the main thing. Here I just do the exact same thing where I store the different thing into the R, G, and B. So the first one being the R, G, and B again. It's just like, you know, it's like when you work with it's all about like trying to find material that you can use in comp to make your life easier. So like, you know, this will be like, just give yourself few timings. That way, like, you know, with one setup render, even though it's pretty fast to render, like that way you don't have to like go back and you can start prototype stuff in 2D, and it can make your life a bit easier to do that way. And here it was just like the same sim, but with just remapped with the ramp, and that way those were like giving those nice shockwave looking thing. I call them rings. So yeah, that's about it. Like just then attribute transfer, and you copy this to the mainstream. Then we have our distance AOV. So distance here, this was the okay. So this was directly like, you know, the animation that we had when we did the our propagation noise, the thing that is driving our whole effect. So I just want to store this, and then in we have an attribute promote per cluster, so that way you can add the solve version or like something sharper per cluster, and this one was per cluster too. So like the cluster name too. So you can see they're like a bit more fractured than this one. So this was just like, yeah, like the storing our animation and where the main displacement is gonna happen. Then we're just matching the animation, and then we're going to go through like the activation stuff basically. So here I just bake something directly, I guess. Yeah. So like it's very always a bit the same method, just finding neighbors and like in the distance, and then we just when I transform them, I just then activate them based on different distance. So here we have 3, 1.5, and this one, what was it? Oh, this one had like a max threshold as well. So like if it was higher than 4, it would go back to 0. So yeah, just like, you know, a few stuff that can help you control. Here basically what I want to do is have something that goes pretty hot when it starts to crack. So that's why I use this technique. So yeah, then I just store all those, and then I did the exact same thing but with some cooling off. So then like this is the exact same thing as the ray. I just keep the activation frame, and then I just have like different fade out basically. So here it's fading out in 10 frames, this one in 25, this one in 50 frames. But you can see that it's starting white and then like it starts to fade off basically. So like all of those are like different, yeah, this one I called it cool, the other edges. And basically like every time, yeah, just copy those attributes into the mainstream, and then after this it goes through our good old take shader. So we go for take here. And you know, here I just add all those attributes one by one, and after I just add those AOVs in the Arnold ROP, and that's basically it for the tech pass. So you can see here we have, so if I just were to sum up, we have something that is driving the shader switch. We have like something a bit ringy that we can use for like drive a glow or something. We're keeping the initial animation and noise that is to drive our effect, and here we're just, to be honest, is one of the most useful. We're keeping the edges just to make something hot and to drive some glow when stuff are detaching. And here in this case, just like if you want some noise that the same type of thing, but that's cooling off, and then just two different types of noises. Sometimes they can help as well blend two shaders, like, you know, if we don't want like a very obvious reveal between two, you want to bring it up a bit more, you can use some of those. So yeah, and basically those are rendered as emissive, so they cost almost nothing to render. You just need to load the thing, but then like once it's loaded, it's just an emissive shader, so it's like you don't need any lights. If I were to go here in the tech, you know, we can remove any lights. You don't need to compute any arrays. It's just this pass. In here, in output, you can switch to deep OpenXR. That way you can also like use some deep merge in compositing, and so that's a fake way, like, you know, something to kind of fight the limitation of Arnold not being able to give us deep with GPU. So I guess that's about it for the Houdini part. So I guess now what we can we can have a look at the Nuke script that I used to generate those shots, and we can go through it, see a bit what I tried to do, and hopefully you get a few comp trick as well. I'm not like a comp or anything, so I don't have like a master knowledge. Maybe there's like a way better way to do stuff in Nuke that I did, but at least, like, you know, we you can, like, the important thing when you do FX is just be able to prototype stuff, and then like you'll have a competent person in comp that can actually even bring it forward and further actually. Cool. Well, thanks guys, and see you in Nuke. All right, so now we're in Nuke, and we're going to have a look at how the thing was comped. Again, not a compare or anything. So like just basically just knowledge you can, just to show you basically how you can prototype effect, and then someone with deeper comp knowledge will take over. But basically here, like all this red part is the background, so the thing that we didn't really work on, but I'll still show the process. So it was like taking the sky, like color corrected defocus, and just make it look a bit dramatic. They had some like DMP images of core sound that I just, you know, merged, put in plus defocus as well. I render like just a few images of my destroyer and destroyer assets, and you can see the difference between the actual just CG render that was not very well lit, but just with the fact to keep all the light groups really help to isolate a bit those strong highlights and make them blend all together. Then I had the city, same, looks pretty flat in the render, but then just make it look a bit dramatic. You can see even like I just basically placed some stuff, but there's not even real ground or anything. Then I placed some statues, another statue, some grading. Then up here I put some stock shots of fire, some embers, and a bit of fog. I don't know if I kept it at the end. So that was like the main background assembly. And I did like as well a few flying cars. You know, that just then moved and mirror and moved in 2D basically. So this is basically like the whole background thing, so we're not very interested into that. Here's already more interesting. This part is basically the main character, so like our effects. So basically here we have, you know, the different the different renders. So as I mentioned before, I rendered the mask with different shaders. So this one, those two are actually the same shader, but like with different bump amount. That way, like, you know, if I want to, basically I wanted like a softer transition between something that looked a bit more pristine and then like, you know, getting all the rusts going out and then fully rust material here. So basically how does that work? So we start with this one, then we do a merge over B. The most important thing is also just to do also merge all for all of this, because then we're going to shuffle and use different AOVs and light groups. So we need to make sure that all the light AOVs are also merged. So, you know, we start with this one, so in B, as it is the first layer, and this one on as A. And then here in the mask thing, we're going to first take our render, our text pass render. So when you see basically, this is like the render dimension where like we don't need any lights. We're just going to store everything into AOVs. So like, you know, with different colors. And so basically like you can put a no up. There's a bit like a null or an object merge, and you can hide input. That way I just link this to my text pass. And here I took, you know, our switch AOV. I took some noise as well. So here you can see that I didn't know if I used the blue channel of the noise. This one I used the blue as well. So like you do a shuffle, first shuffle just to bring the AOV you want to use here. And after you say, okay, I want the blue, so you put the blue and everything, or I want the green, put the green and everything. Then I just, you know, grade a bit my noise, clamp them as well, because basically what we're trying to do is like, you know, break a bit the transition between the two. So that's why basically you want to multiply it. So like you want to have some dots where you have 0 and some values where you have 1. You know, so like that's why it's important to clamp it, because otherwise you might get like very high in values. So yeah, basically that's about it. And so this would be like, you know, where we create our transition between the two states. You can see the rust start to get infected here. And then what I did as well, I just did like another keyframe A over B on top of this, just to make something as well that progress a bit more uniformly on top of this. So yeah, that's basically the same technique that I use for the transition or state B. You know, this time I used the red channel. Like, you know, this one, our red channel was delayed compared to our blue channel. So yeah, like, you know, I use this one in terms of the other, still breaking up with noise. So you can see like it starts to appear a bit later. Cool. And then I do the same technique, just merge it. And, you know, just color corrected, animated some stuff just to do the blend that I like. You know, at the end I just want to blend a bit more, so that's what I do. Like, you know, like that's why I prefer to do those kind of stuff, the transition of shaders in comp, that way you have more flexibility and you can try different things in timing. So basically the thing you need to do is just use this R thing and put in the mask, and then it will switch from one shader to the other. So if I go to here to the last thing, so we start with this, the very first shader, then we go to the second one, and then at the end the third one, the rusty one. Cool. Then I merge this with the robe, the eyes, and all this. And what I do as well in the tech pass, I copy some stuff into the main thing, basically mainly noises and edges. That way I'll be able to use them later. Cool. And you can see after, so basically I have a lot of, like, you know, no up, they're pointing to this node here. And basically now I start to do shuffles of the eye. So, like, you know, I can color correct how strong we want it to be, add a bit of glow. Here I take the sun. So you can see basically those are like the light AOVs, or RGB8 directional. Is like this light pass. So I can either or not reduce noise if it's a bit noisy. You can like do denoise per AOV like this. But basically, like, at the end I didn't touch too much any of that. So I think actually I can delete that. At the end I think I just color corrected. So I just give it a boost. So this is like this was the sky, so I think I just grade the sky a bit more in the red tone. Now we have, like, you know, the sky, the directional, and the eyes back. Where there are inside light, light group. This one's a bit more long because I just put it reduce noise. Yeah, so basically this was done from like the our mesh light underneath the mask. And I try to push this quite a lot just to get those nice dynamic light interaction. Here, this was a glow with distance. So basically I just, you know, used one of our AOVs. I might just need to clean a bit this. So yeah, like you remember this one, I took just one channel, like the green. Yeah, I just use the alpha anyway. And basically here I can, you know, grade stuff based on this. So like I just decide to give it a boost in the orange red tone when it's getting away. Then the inside mask. So, you know, isolate the surface behind the mask. I just color corrected, graded. One thing that I like to do is reduce the gamma to make something a bit more contrasty, a bit more like lava. Then I just put some glows. The glows, you can put them as FX only. That way you just, you know, what I like to do is have a small glow and a big glow. Obviously the big glow, you try to make it less less bright. So, like, you know, you got something a bit flat like this to something a bit more that looks a bit more hot. And then you merge that again. This is what you get. And after that, this one, so I didn't use it, so I think we can remove it probably. It's very subtle, so I think we can ignore it. This one was another light coming from the cracks. I might actually show you how to do it. I don't think I did. But basically, yeah, it's just like another type of mesh light. I used our tag passes and I just scatter some sphere just to get some light interaction that was targeting a bit more the outside of the mask as well. So just playing with this helps like reduce a bit the contrast of everything, making everything a bit brighter. Then we have our edges glow. This is more at the beginning, actually. Well, I mean, even till the end, actually. No, I think okay. And then basically I animate some color corrects just to have some stuff that, you know, die a bit over time. But it was, yeah, at the very beginning to isolate those cracks here. Let's see. Just otherwise, it felt a bit underwhelming. You didn't see too much of cracks. This was done with the groups. Then we put a very strong key here just to isolate the part that we want. And then we just take our distance AOV, multiply it, just so we don't use everything. And then, yeah, we just grade it and to the colors we like. So like this kind of dark orange, put a bit of glow on it, and then merge everything in plus. Usually, basically, emissive stuff, you try to measure them in plus, and the other you measure them in over. So that's what you get. Then we have the rim lights. So shuffle, take those lights, try to make them a bit more red. So you can see like it's mainly about like try to split all the component of your effect and of your shot and try to tweak it. So here, for example, it was getting a bit too dark, you know, so we have also like our last light called the fill, and we're trying to boost that up a bit and see like now it's making a bit more appearing some of the stuff that are like hidden under the robe. Okay, and then like basically when we're happy with it, we just need to recopy the alpha. That way, like, you know, we have our good alpha from before and not just like a broken alpha. This is pretty important. So here, same as the no up, going back to this where our alpha was good. All right, cool. Then I just added like this small particle layer here, a bit subtle. Those were rendered directly with the you can see, yeah. So like basically here the idea was to create a bit more contrast, so putting back some black edges. And yeah, those were rendered with the mask destruction as matte. Then here we have our inside stuff. Our inside surface, we merge it together as well. And then we have our latest cracks glow. So here basically I tried to take the edges from our tech pass. Yeah, try to color correct, try to get something basically just to that look a bit like small pieces of small sparks almost that would stick on the surface. And then after this, then I just animate the color correct just to make it a bit brighter at the beginning and less bright at the end. Just to make it a bit more dramatic. Something that we didn't really do, but we had like the fur as well that renders separately. Just merge top of this. I'm going to switch back to this one. Cool. And then like once we have this, I merge this to the background, and now we can work on our secondaries. So we have this layer called lava emissive. So that was the same thing, but just the same layer but rendered with this lava thing. So at the end, I just end up using the emission of it. And it was the same thing. I just used, you know, our tech pass, shuffle some noises. In here, shuffle our distance thing, and I multiply stuff between each other. So I have like this lava thing multiplied by this, gives us this, and then it's merged with basically like the overall alpha thing that they just keyframed just to get something that looks a bit subtle at the beginning, and then gradually gets a bit more emissive. I'll try to see what's the bottleneck. Okay. So yeah, before, after. So like now we try to add a bit of those small lava details that are appearing. Those are just textures, by the way. So it's not really FX related, it's more because it looks cool. Then we have our smoke, the main smoke that we render as emissive. Here I just do the roto because I didn't like too much the smoke near the nose. So you can just do, right, you want to do a patch, you can do like a small circle that you just put as replace, you invert it, you blur it, and you multiply it. You can see that now we're reducing a bit the visibility. Then I make it quite dark, merge it over. Okay, I will see some of those details. Then here, this is the part with the glows. Something a bit subtle. Just add it on top on as plus. Then we have our thin smoke. So this is the smoke that was not rendered with the emissive shader with a bit more brilliancy and less dense. So I just graded a bit, just more in the orange tone, just so it looks a bit better and integrated. You can see it's a bit subtle, but like, you know, it really helps filling a bit the gaps. And then here we have our advected particles. So yeah, this is one of the layer that makes a lot of difference. Here I just do reduce noise as well, just to make it a bit smoother. And then I just merge them in and under average if I want to do something that can, like, you know, go from one layer to the other. And here, yeah, I just try to have something, I put a bit more red, a bit more bright. And here, yeah, sharpen it, put it as plus. So this one is really like going to give us those highlights and detail that we like. And yeah, then just a bit of glow to make it look even more magical. Then we have our small debris that we add. So yeah, nothing really fancy here, just some color correct, and try just to integrate them. Then what do we have here? So this at the end, I think I didn't use it. so we can remove it. And for like the FX layers, I think that's more or less about it. We have a few stuff still, yeah. I add some foreground embers, some just stock shot here in this case. You know, and I really defocus them quite a lot, just to make them look cool. And then we have our rays. So same, that we just have this roto just to remove the thing that was on the nose, was not super beautiful, and just try to make them subtle and not overtake the effect with this. Otherwise it can get like, you know, a bit too, I mean, depends on your case, you know. But yeah, in this case here I just made it pretty subtle. Then we have our beautiful smoke in the eyes. So yeah, I just do a bit of a tweak here, and in comp I just isolate the eyes, just erode it a bit, and then I just multiply it just to have some like a fail off that works a bit better. So just can show you the difference here. I thought I was going a bit too much out of the eyes, so I just, you know, manually reduce that amount. Small touch, but like, you know, it brings something cool, brings a bit of motion in the look. Then I bring some flares, so I take, you know, our DMP thing and just make sure everything is masked and add a bit more flares. I think you maybe see it a bit better in the beginning. Yeah, this kind of flares. Then, like, you know, I reuse those alpha just to multiply, to make sure that I don't put this on top, you know, otherwise it looks really weird. But like, this really helps to give a notion of parallax as well, as they will get like masked by the guy after. Then I just add a bit of glow on top of this at the end on the eyes. I add few smoke plumes, really nothing fancy here. Just take this, invert them, place them, make them a bit orange. It's a pretty subtle element anyway. And yeah, those are just some low density volume I had near the fire, just to give the feeling that there's a bit more volumetric near the background fire. Some more embers that we put more that are coming from the mid-ground fires. And I just add a pretty strong vignetting. So to do vignetting, what I usually do is I put an ellipse like this. I do replace in the alpha. I invert it, blur it, and then I just use this one as a mask in the alpha. And I just grade down everything that is on the side. And then here I add some lens flares. And then here I do some chromatic aberration. So basically here's to always break a bit the CG look. And basically, so chromatic aberrations are, you know, a shift between the red, green, and blue channels. So I just take on one side the red, here the green, here the blue, and I just scale a bit up the red and scale a bit down the blue, the blue, and I just merge them back to plus. And you can see that between the two, we have this small shift, especially on the sides as we're scaling up, not that much as our anchor point is in the middle. We don't have that much stitch in the middle, so we have something that stays a bit sharp, but on the background we have something that goes a bit more in those rainbow colors that we like. Add a bit of cam shake that I keyframe as well. Keyframe the amplitudes over time. Here I tried to do some glints, but it wasn't working very good. And then you're just, final grading. So here I'm just me reducing a bit the gamma to get a bit more contrast. And yeah, that's it. So we go from essentially this to this. It's not that impressive on the first frame, but then after, if we go to a later frame, let's take the last one actually. All right, cool. So yeah, if I were to go back between the two, go from this like to do just a pure CG without any secondaries, and see that like our here our Advected particles plays a big role. The small debris as well are nice because they're bringing a bit more contrast at the end of in the image and a bit more details. But yeah, so that's for the comp part. And here, this is like more like in studio we like to do this just to show supervisors like our options. So if you were to do like it's called an AOV Contact Sheet. So like here I just put a no up and then do some shuffles on my different paths, put a text and put a contact sheet. Now we can show a bit like the different IDs and talk with comp, say okay, I did this, I had this in mind, this to use it that way, and then like open the conversation. And it's more like for the secondaries, so same technique. It's just like no up, using no up like this just makes stuff a bit more organized, especially if you hide the input. So basically, yeah, that's what we do usually in studio. We do this type of contact sheet. And yeah, that's it. That's about it for the composting part of the tutorial. I hope you learned a few stuff, and yeah, see you next time.